Hello, this is Sean again with Surviving Networking and IT, and we're back for a special video for someone on Reddit. They were asking, how can I let two routers talk to each other like this? Hello, I have a setup at home. Diagram. I need to know how I can make this work. Total newbie, so I don't know much, but I just follow guides. Basically, each router should have its own internet like shown, but a computer connected to the Mikrotik router should be able to see the printers or the other computer in the network. I did a little research and someone said I had to make a static route. How can I do this? This is where I can add the static route on the TP-Link router, and it gives a little diagram of that. Any help is appreciated. Well, I'm here to help you out with this. Let's go ahead and take a look at the diagram. Diagram is like so. We have DSL coming on over here, Mikrotik router to AP, which then connects to the computer here. Another TP-Link router, a TP-Link router on the right. Looks like it goes out via DSL, just like the other side. It's connected to a switch, which then that connects down to a printer. And then from the switch, it connects down to an AP, which then a computer is over there. Well, let's go ahead and convert this into a diagram on diagrams.net. And go ahead and pre-made this. This is very similar to another video I did last week or the week before on episode 1. We're connecting two routers together, but with failover. This one's not talking about failover, so this is a little bit different, a little bit easier, and a little bit quicker to go through. So we have the internet over here, connected to the WAN port. We're gonna just say ETH1, Ether 1 right here. Ether 2 connects over to the other TP-Link router, which then has its own internet. We're going to assume the TP-Link router is like most consumer routers, where it has all the LAN ports are one VLAN, one network. This connects over down to the switch. The switch then connects to the printer, an AP, and that connects to the computer. And over here we have the similar where Ether 3 is going to connect to this wireless AP down here, which then it will connect to PC. Let's go ahead and see how we can replicate this in GNS3. And this is the dual failover lab that we did before. So let's go ahead and make another lab with this. Say two routers each other. Static routes. Okay, so I've made a new lab. We're gonna go ahead and take away all this. So we're not gonna delete the switch. We're gonna keep that right here. PC down here. Look at the diagram one more. So we have an AP, PC1. Let's go ahead and do that first. Now, in GNS3 and other simulators, it's very difficult to simulate RF and wireless connections, so we're just going to make the access point like a switch. A couple of these. 8. In. Just call it AP. Another AP, and then we switch. Since these are all going to be untagged VLANs, we're going to go ahead and configure it as such. All these are going to just be 1, 2, and change this access. Okay, so that's all the same. And we'll go ahead and 8. Okay. We have AP2. Just a switch. And let's start getting things connected together. One too many PCs down. Let's go ahead and get some of these out. I call this printer just to simulate what they have on. pick here. Connection in Ether 3. This we'll just say, doesn't matter which port, let's say Ether 1 here, 2 to the PC. We're going to connect to these two micros together. Ether 2, 2, and 3 switch. Connect Ether 7 of the switch. E. 1. And then Ether C. Switch is going to connect printer. All this should be very similar to what the person has at their. So we have E with a PC, other AP with a PC. It's devices. And we'll go ahead and get these configured. So let's go into console first. Super secret password. And looks like we need to label this. So system ident is important. Ident 1. Set name 1. Yeah, say R1. And we're doing the same thing over here. So sys ident name set name TP R2. Okay, so got that the identity set in console. Go ahead and get connect the internet. In theory, it should be very similar to how the gentleman is set up. Over. No. I'm assuming the person wants to have this PC1 communicate all through this. Come over here, be able to communicate with this printer here or this PC2. The way to do this with static routes is essentially these are the traffic directors of where things are going to go. So let's just say the network 192.168, say 1.1 slash and slash 24. See if he actually labeled it. He did. It is $1. Over here is $88. So we'll go ahead and simulate that in here. His home LAN is 1.1. This. And over here it's $88. So that's the IP of this router here. Right here. This 10 again, and we'll say .11. And we'll say this is .055. So we have two different local networks that we need to communicate with each other, but they need to go out their own separate internets. It's important that each side is not stealing internet from the other side. Let's go ahead and label. Showing that. Okay, so all the labels turned up. We have the configuration initially started. Let's go ahead and open Winbox. The Winbox, and I want to connect to my Roman. Here. And we need to look for 2 router. It's like I do not have my running properly. It's a little unfortunate. So I'm gonna get Roman, keep going. Super. Something simple. Is this for labs? Now, OP, I'm sorry, this is going to take this a little off the rails just for a second so I can get this all configured. This makes it nice and easy. Screen. So, now that I have that done, let's see if I can see the 2. Hey, look, we have R1 and TP-Link R2. Super secret password. And same thing, the one. I think. Okay. We're going to go ahead and move this off screen. And we're going to get the Mikrotik configured first. Let's look at these. Okay, so it looks like, yeah, this is the max we can magnify in, so I apologize if you can't see this, but this is the best. We're going to go to IP address, and so let's get rid of this VLAN, LAN bridge. That, go ahead and really back to basics. This is going to be LAN. Two, and I'm coming actually IP addresses, bridge, like a LAN bridge, port setup, and ports. Nope. Okay, I see what actually using the interface list. Sorry, it's going to pull VLANs. No VLANs on here. Wonderful. So Ether 3 is connected to the LAN. LAN bridge. We're going to set this 192.168.88.1/24 network. Now we have the IP just like he had on his diagram. From here, we need to make sure DHCP is set up properly. Get rid of DHCP, set the LAN bridge, and next all the in theory, this initial setup should be ready for testing on one side. Oh. This PC, if I go to console, small, let's see if I can reach the. Alright, that looks like I can easily do. But we're going to go ahead and do DHCP. This. And we have an IP on this. So it's on 88.250. We're gonna have to use that for now. Now we're gonna go ahead and configure the other side to make sure that's all set up for that subnet. That box. Now, obviously, he has a TP-Link router, and it's not tick, and that is different. So I can't emulate a TP-Link router in this, but we're gonna go ahead and do the best we can with this. Go ahead and set this to 2.1. Looks like I already have a basic LAN bridge already set up to go. Bridge, LAN ports, that's wonderful. Okay, looks like ports that one has an IP out to the internet. And let's check the, looks like there is a source net set up. So this is virtually set to go. Let's go ahead and check DHCP set up. LAN bridge. Next, and that is now set up. Let's go ahead and check the printer and computer over here. So on this, DHCP, and it does pull an IP on 192.168.1 subnet, and the printer should do the same. Excellent. So both of these pulled IP on the 192.168.1 network. PC1 is on the 88. Network. Now, if we try to ping across, it's not going to do anything. Let's go ahead and try it. We're going to try to ping the router. A timeout. Same thing if we do the other side of this. Try to ping 2.168, 88.1. Going to go nowhere. I'll explain. What this PC is doing down here is sending the ping out its interface, hitting this AP, just like a switch, going to this switch, automatically touching this TP-Link router right now. This TP-Link router looks at its routing table and says, do I have a connected network on this router? If yes, send it out that directed route. If no, send it out the default route. Currently, this TP-Link router does not have any additional routes set up. It only has the 192.168.1 network and the default route, which heads out to the internet. Right now, we're trying to communicate to the internet, and of course, private IPs aren't available on internet. Multiple two reasons. So, what do we have to do first? First, we have to set up a third network between the Mikrotik TP-Link. Typically, you would set up in a commercial environment, you set up a point-to-point network, but since the TP-Link probably doesn't have the option to do that to additional networks, we're going to have to steal or borrow a network. This is on the 192.168.1 network. What we have to do is go to TP-Link and reconfigure the address pool. Hopefully the TP-Link has an option to change the DHCP range. I'm changing the range from .2 to 51 to 54. That leaves 50 IPs available below that to be able to use for the connection or other devices. That is off the screen. I'm going to go ahead and get the Mikrotik Ether 2 connected to this network. Just confirm Ether 2 is not a part of the bridge. This is the tip line. Like, this is the tip link. This off the screen. Other one looks like a modified Mikrotik ARM. And for the most part, it doesn't matter. This pool already set up 88 network. But it doesn't matter for tip links. Fix that. Cool. 1.network. Change this to 51.4. That's changed. Now we can move. Check back. And we're going to go ahead and double check. Make sure that ETH2 is not a part of the bridge. Check the bridge. LAN ETH3 6. That's fine. There's all the LAN ports. And we're going to go to IP address. Add another address. Can do this through DHCP client. Not recommend that because it can fork the static route. Set a static IP for this, please. 2.168.1.2/24. This is going to be on 2 line network. Now, from this device, you should be able to communicate with the other router. 2.168.1.1. And look, we're getting a response from the other router. Not a problem. That is wonderful. Go ahead and pull up the tip link router. We'll put side by side. See if we can ping the other side. 1.2. See a bigger screen. I want a bigger screen. Hey, look, okay, it is working. Just couldn't see it. It was off screen. Stop this. Window. Here. Now we need to make a static route on each side. I'm going to show the Mikrotik side first and then describe the same thing on the other side. However, it will be different. TP-Link have different screens, but it will have similar namings that you should be able to use to translate into this. So we're going to go to IP routes and get rid of any static routes we had before. And we're going to say destination address. This is the subnet you want to communicate with. Everybody knows the subnet. It's 192.168.1.0/24. This is the whole network that he has on TP-Link router. Gateway will be 192.168.1.1. That's the other side of the connection for this Mikrotik router. We're going to go ahead and set this to check gateway by ping. Come down to distance. We're going to set this to a distance of, say, 20. It really does not matter because this is a very specific static route. And when we hit apply on the Mikrotik, we can see that gateway is reachable via Ether2. It knows the connection. And basically, anytime a computer from the Mikrotik side needs to reach over to here, it'll go through Mikrotik. Contact, go over to the gateway over here, and then the network, it will go. Now that we have that all set, shows reachable. Pull up the TP-Link, do the same thing on the other side. IP routes. Add a route, destination address, 192.168.88.0/24. The gateway will be 192.168.1.2. That's the other side, same link. Check gateway with ping, distance set to 20, apply, and it is reachable via the LAN bridge. Completely fine. Now the two sides should be able to communicate with each other. So we'll pull up PC2 and see if we can ping PC1. PC2. So actually, we'll just go ahead and see if we can ping the router on the other side. And look, we can ping the other router on the other side just fine. See if we can ping the router from the Mikrotik side, from PC1. We can now ping where we could not ping before. Go ahead and make this a little more specific. 2.168. I think it's 253. 3. And I can ping the printer on the other side. And see, let's see if I can see one. 2.168.88.2.4. Ping. and they both can ping out. And to show this how this works, let's see if we can do a trace route. Yeah. Yeah, I forgot. This does not have the ability to do trace. That's quite alright. Oh, sorry, it's called trace. Trace 192.168. 88.254. This shows that it's the first hop is its own router right there, and then sends it over to the other router on 1.2, and then it ends up at the PC on 192.168.88.2. Same thing the round. 168 to 1.4, and it goes to its local router first. Then it heads directly over that. Sometimes you won't see all the hops because this is virtually a single hop because it's on the same network as PC2. So essentially, PC2 on the same network as this interface right here on the Mikrotik. So it goes to here first, hops over directly to the PC2. It doesn't even need to go to the router, even though the router facilitates the communication of two-way traffic. If you wanted to make this a little more fun, you could just set up one DHCP server to serve both sides. But this is a scenario you might want to use if you had two apartments side by side. Friends with your neighbor, and you want to share internet, or you just want to share local resources like a NAS or a Plex server. Drill a hole through the wall, throw an Ethernet cable through the wall. This would be here between the two connections, and you just want to basic sharing without taking complete ownership. I hope this helps somebody out there, at least the guy on Reddit. And if you have any questions, join us on the Discord. Thanks for now. Bye.